Okay, in this video we're going to start talking about, areas and circumference of circles, as well as area and perimeter of rectangles and squares, most of which you've already learned in grade school. So I shouldn't have to spend time on some elementary problems, so we can have problems that are of a little bit more interest, okay? We know in a circle, sorry, this keeps on moving ahead. In a circle, the diameter is labeled in blue, the radius, half the diameter, is in red, and the circumference is the distance around, which is in green. We know that the area of a circle is pi r squared, pi times r squared, okay? The circumference of the circle is pi times the diameter, or alternately pi 2 pi r, since the diameter is 2 radii. Okay. One thing of interest, we know that radius is half the diameter. The way in which pi was determined was, to measure the distance around the circle, the circumference, and dividing that by the diameter will give pi. That doesn't matter the size of the circle, because it's a ratio. So for any circle, if you measure the diameter, take a string and wrap it around the circle, then disconnect it and measure its length, then take a string and measure the diameter of the circle, divide the circumference by the diameter, it will always give you pi. We're actually going to be doing an exercise in order to see how close we can get to pi in one of our forthcoming exercises, These are simple problems. These are grade school problems. These are not the kind of problems that we're going to be seeing, because these are not the kind of problems that we standard expected of high school students who are going to ask to take the SAT test. And so we will in this slideshow start looking at kind of problems. Area is pi r squared, 16 pi. Leave pi alone. Leave it as pi. This is the diameter. The area is the radius pi r squared. The radius is 8. That would be 64 pi. So those are pretty elementary problems. Likewise, the circumference. Not the kind of problems you expect to see. Pi d, 3 pi, 80 pi. Leave pi alone. Leave it as it is. They're simple problems. Expect something greater than that. What about our area formulas or perimeters for squares and rectangles? You know all those. Perimeter, is the sum of all the sides. For a square, all sides are equal, so it's just 4 times the length of one side. If the side is A, the perimeter is 4A. Likewise, over here, rectangle, 2 lengths and 2 widths is the perimeter. 2 lengths and 2 widths, or alternately, 2 times the sum of length and width. Area, side squared, A squared is the area, length times width for a rectangle. You know those, Don't expect these kind of problems, What is the perimeter? Well, it's 2 lengths of 4 that are shown and 2 that are not shown. So 4 and 4, 4 fours are 16. It's just, now this is the perimeter, which is measured without square units. Sorry, keeps moving ahead. The area is 16 square centimeters. The area and the perimeter are not the same here. Do not make that mistake. The perimeter is 16 centimeters. The area is 16 centimeters square. And over here, perimeter, you say, well, how did they get that? It's only 4 and 8. But remember, here's the other formula. Add the length and width together, then double it. Add the length and width together and double it. So we looked at those. We look at those. What are these? You can't even hardly see them. They're not worth seeing. They're asking for the area of the perimeter. There's nothing complicated. You can see by the little figure down here. These are grade school problems, okay? We're not going to insult you with them. Let's look at some more interesting kind of problems, okay? All right, here's one. Find the perimeter and the area. Now, it's going to be up to you to do these. I'm going to make some suggestions, okay? And that's what this video is about. So here's the perimeter. What's the perimeter? Sum of all the sides. They say, well, I don't have this side. Well, sure you do. That side, look at segment addition. It's 2, 3, and 2. So that side is 7. And you say, well, what about the base down here? Well, the same way. This length of 5 comes down, the length of 3 comes down, and that comes down. So that's 4, 7, 12. Okay? So you do have the perimeter. Then you say, well, what about the area? Well, now you have the perimeter. You have the one side is 7, the other side of the big rectangle is 12. So take the big rectangle and then cut the pieces out. Cut out the rectangle here, which is 2 by 3. Cut out the rectangle here, which is 3 by 4. And there you have it. Okay? Now here, what about this one? It says find the area in the regions A, B, C, and D. Well, A, B, C, and D are these regions. Looks like a picture frame of sort. But, okay, what is it? That area is basically the area that is outside of this smaller rectangle, which measures 6 by 8, and inside of the larger rectangle, which measures 8 by 10. So basically, the area in the regions is the sum of, is the difference of the two areas. Take the area of the large rectangle, 8 by 10, subtract from it the area of the small rectangle, 6 by 8, and there you have it. What about the area of the shaded region? Similar to just the previous problem. This is a washer. The area of the washer is the area outside the white circle and inside the larger circle. So what do we need for area? Pi r squared. Okay, so it's big R, which is a radius of what? Well, okay, here it's showing you that the diameter of the smaller circle is 100 meters. That means its radius is 50. And this is saying the AP length is 5. So if you went from O to P, that's a distance of 55. That's the radius of the outer circle. Okay? So the outer radius is 55. Okay, the inner radius is 50. So the area of the outer circle, pi r squared, 55 squared times pi minus 50 squared times pi. Okay? Find the area in the perimeter. So this is a figure called the Norman window. The Norman window. What is it? Well, it's a rectangle with a half a circle over top of it. Okay? So therefore, its perimeter is going to be the perimeter of the rectangle less this. Don't include that dotted side because that's not in the perimeter. What you will include is a half of the circumference of the circle. But you say, well, what's the radius of the circle? Well, look, this length down here of 8 is the diameter of the circle up here. So then the radius of the circle is 4. And what about the area? Go back to that. What about the area? Well, it's the area of the rectangle plus the area of a half a circle. Okay? You can do it. It's not difficult. Okay? What about this one? Well, again, what's it saying? Find the area? Well, what is it? It's a rectangle whose dimensions are 12 by 22, less a half a circle here, less another half a circle here. So it's the rectangle minus the circle, whose the area of the rectangle minus the area of the circle. The radius of the circle is 6. That's it. Leave pi as pi. It's fine to leave the computations with pi. It's actually more exact. Don't worry about it. Okay? This is an interesting figure. I'm going to let you think about this one. But basically, okay, we're asked to find the shaded region. Okay, now you can see that the entire large circle has a radius of 6. I'm sorry, has a diameter of 6, a radius of 3. So if we start off with the all-inclusive circle, the circle of radius, sorry, keep going back there, the all-inclusive circle, radius 3, okay, we could say that it has an area of 9 pi. But then what we want to take away from that is this semicircle down here, whose radius is 4, and then we want to add to that this radius, this semicircle, whose radius is 1. So, you know what it looks like? It looks like the following to me. It looks like, okay, 3 squared pi, that's 9 pi, minus 2 squared pi minus 4 pi plus pi. And that's not so bad if you think about it. Here's one of the designs we created. Okay? Oh, come back. Okay, what about that? What about that design? Well, how are you going to find, it says to you that the area of the larger square is 100 square inches. Well, 100 is 10 squared. So that means each side here is 10 inches. It's a side AB is 10, BC is 10, and okay. And then, well, what about F, E, H, and G? They're midpoints. So that means, okay, the length from B to F is 5, or B to E is 5. So guess what? Okay, there you have 5 by 5, and that's a triangle. Remember, for a triangle, it's the area half the base times the height. A couple more for you to think about. Okay, so you should be able to find that. You should be able to find that and justify that the area in black is half the area of the whole thing. Okay, interestingly enough. Okay, all right, let's see. Here's a good one. Very interesting problem. Okay, what you want is the area in gray here. So, well, obviously, it suggests to you that we take the area of the entire figure, which is a rectangle, and subtract the area of all the circles. But you say, well, how can we find that? Well, look, what's it say? Each one has a diameter of 6, has a diameter of 2 inches. So 2 inches, another 2, another 2. So it looks like the side here is 6 inches, because it's 3 circles which are all stacked up on each other. It's said to be tangent. They're just touching at these points right here. So the width of the rectangle is 6. What's the length of the rectangle? Well, 2, 4, 6, 8. Well, there it is. The length of the rectangle is 8. 6 by 8. Well, 6 by 8 is the area of the rectangle less all the circles, which is what? Well, we got, okay, 3, 6, 9, 12. So find the area of one circle. Oh, what's the area of one circle? Well, it's pi r squared. This keeps flicking back on me. I'm sorry about that. The area of one circle is pi r squared, where r is 1. So each circle has pi. Pi, 12 circles, 12 pi. Not so bad. You should be able to take it and show the work that gets you that solution. Here's a twist on that one. Just looking for this area. This is very interesting now. Okay, what's it say? Given each circle has a diameter of 5. There's a diameter of 5. Well, if the diameter is 5, the radius is 2.5, but these segments then connect from center to center of each circle. So this is a rectangle, which is, I'm sorry, it's a rectangle. It's a special rectangle, square. So it's square 5 by 5. So what is this? What is this area in the shaded region? Well, look at it. It's the rectangle, the square that's shown here, less a quarter circle, another quarter circle, another quarter circle, and another quarter circle. So not so bad. Think about it, man. Not so bad. That's it. There's some fun problems. I hope you have fun with them. Follow the suggestions that I made in each and every one, and enjoy solving some area and perimeter problems you know, that are on the level with SAT prep stuff, okay? So good enough, and we'll be able to work on these in class, okay?